Hello and welcome to All Things Aviation and Aerospace. I'm Vince Mickens, and I'm very much looking forward to our discussion today about the possibilities, the opportunities, and the options in human space exploration. Joining me, our guest co-host today, is Brooke Harrington. Brooke is a recent graduate from Embry-Riddle Aeronautical University. She graduated last year during the beginnings of the pandemic, which kind of threw a curve to her career as on a professional pilot track, but she's plugging along. As a matter of fact, Brooke is currently working on her MBA with Embry-Riddle Worldwide. And even though she's been grounded a bit, she's trying to get back up in the air and continue her quest. In the meantime, we had a pretty interesting conversation the other day because she's actually learning so much about other opportunities in both the aviation and aerospace worlds that it's giving her ideas on things that she could do beyond just flying as a professional pilot. So looking forward to that. Welcome to the show, Brooke.
Thanks for having me back on, Vince. It's a pleasure to be here. And yeah, just checking out different opportunities. I'm very excited for today's webcast. It's going to be very, very interesting.
Yeah, well, really glad to have you today, particularly since you're a recent college graduate, specifically aviation oriented, and have the interests that you do. So you can give great perspective on that with regard to the two aspects of the industry. Then I'd like to now introduce welcome two very special guests today. First is Dr. Pablo De Leon, who's asked me to call him Pablo. But Dr. De Leon is the department chair and he's a professor of space studies for their master's program at the University of North Dakota. The space studies program at UND includes topics such as human spaceflight, space suits, space habitation, and the history of aeronautics. It sounds so interesting. I think I want to go back to school and check it out. Pablo also is the director of their laboratory, which he'll tell us more about. In fact, I think he's actually sitting in it, if I'm not mistaken, or an aspect of it. And they just received a very significant grant for doing more research and that type of thing. So, and as you guys know, we're totally into the world these days with space flight and targeting for first the moon and then for Mars. And it's all about being able to do that effectively and comfortably and things like that, which Dr. De Leon will tell us more about. On the other end of the spectrum, we have the great grandson of the iconic Tuskegee Airman, retired Air Force, I call him super pilot, Brigadier General Charles McGee, who recently turned 101 years old back on December 7th. So I'd like to welcome Iain Lanphier, who is a 9th grade freshman at Brophy College Preparatory School in Phoenix. And we've just been having a really interesting conversation, which some of you may have gotten a taste of since I didn't know we were live earlier than we are. But Ian's an honor student who is particularly good with math and sciences. And as you can imagine, between his great grandfather and his grandfather, Ron McGee, flying genes, Iain has a strong interest in the aerospace industry, including space exploration. So Iain, welcome to the show today.
Thank you for having me. I'm excited to be here.
It's great to have you on the show. So let's go ahead and start a little bit with this because Dr. De Leon, you have quite the background with regard to human space flight and with your specialization, particularly dealing with space suits, et cetera, and so forth. But can you tell us a little bit about how you got started, how you got into space, your interest with it? You can take us all the way back and tell us how that happened.
Well, yes, I will have to take you very, very long way back because I was born in Argentina, and one of my earliest memories is when I saw Neil Armstrong walking on the moon from an old black and white TV in the farm where we were living with my parents and grandparents in very far outside of Buenos Aires. So I think that that's difference between the reality I was looking every day, you know, with the cows and the chickens and everything, and the possibilities of space exploration kind of sparked the interest on me to one day work in space exploration. And of course, when you are born in a country that doesn't have a strong space program, like in the case of the US or say Russia or now China, your possibilities are very few and very scarce. So in my case, I had the chance to come to the United States and be able to develop my my passion, turn my passion into a profession, right? So I have been involved with space since I can remember, first as an engineer working with the space shuttle. In fact, I did seven different experiments in different flights of during the space shuttle program, and that kind of helped me to gain the experience that I needed to later turn into my passion, which is spacesuits.
What kind of engineer?
Aerospace engineering, okay. and then I did then I did a postgraduate studies in the International Space University, and then later I got a PhD in history of science and technology. So I went back and forth from social sciences and science and technology as well. And since 2004, I have been first a researcher, then an associate professor, and then a professor, and now the chair of the Department of Space Studies, where we deal with a variety of different disciplines, not just human space flight, but also asteroid research, space policy and law, a variety of different disciplines that we have in our department. Like as you said, Vince, is a master's and PhD in space studies and aerospace sciences. So we have a super cool group of professors and students and who are really people that are devoting their life to advancing space exploration. So these are great times to be working on these. Let me just mention something. When I graduated, the only thing around was a space shuttle. So there was nothing else, right? So your only chance to be involved with human spaceflight was a shuttle. And nowadays we have this amazing variety of projects and vehicles and companies and organizations that you can be working on. So sometimes I joke with my students, you know, you guys are so lucky, so many opportunities that you have in front of you.
Tons of opportunities. So we have a million questions for you, but we only have an hour, so and less than that now. But it's really for Iain, so he's the one we want to let ask the most questions. But I do want to start things off. It's fascinating that your interest became in spacesuits specifically, and that's interesting, I think, to all of us, because the technology with spacesuits is, you know, technology in itself is pretty amazing. But spacesuit technology has gotten very, very sophisticated. I guess I'm preaching to the choir here, but has gotten very sophisticated, and including, and maybe you can give us some insight on, so like the decision of the design of the spacesuit, the exterior design is an example, in just terms of what it looks like. And then there are several different kinds of spacesuits and things like that as an example. So as we start moving towards going back to the moon and going there to hang out for a while, and then eventually going on that 6-month journey to Mars, what are some of the things you look at, and tell us about your students that also have developed an interest in this aspect of human spaceflight?
Sure. Well, I was always interested in spacesuits because I think that to me, it was, when I didn't understood the basic of it, it was like this incredible anthropomorphical human-shaped thing that protects you from one of the most hostile environments known by humans, which is space, right? So how can it be that just less than an inch of different fabrics applied together will protect you from such a dangerous environment? So I think that by itself, a spacesuit is a miniaturized spacecraft that have to provide everything that the astronaut needs in order to live and perform work in space. As we move further away from the Earth, the suits necessarily have to be more and more complex, because what changes is the environment where we are going to operate. And not only that, early spacesuits were very dependent on Earth. Even the suits that we have in the International Space Station now are very dependent on Earth. We are just a couple of 100 miles away from the Earth. So if something goes wrong, well, eventually, I don't know, Dragon, the SpaceX Dragon or someone else can bring the suit and they can bring another one back, et cetera, et cetera. That won't be possible as we move further away from the Earth. Right. So we need to produce suits where we'll be able to inspect, repair, service, and even manufacture eventually parts or entire suits, whatever our destination is. So the concept of building our suits have to change to reflect that changing destination that we'll be having.
Yeah, that makes a lot of sense, actually. So again, before we let Iain ask his first question, one of the things we were impressed with pre-show is that you were telling us about a 3D printer and things that you make with that there in the laboratory. And Iain said, well, which printer is it? Do you have the this, the that? And he named three types of printers. I mean, what 14-year-old does that? But I guess, they do these days in terms of what they're taught. Can you tell us a little bit more about your use of the 3D printer and what Iain was asking about?
Sure. Well, basically, so far, parts of spacesuits were made in traditional ways. The spacesuit have many layers. Most of those layers were sewn just in traditional ways by people skilled, artisans really, that were skilled in different portions of the suit. And building, for example, something like this is an EVA glove used in the International Space Station. And as you can see, the work of putting this together is very complex. It takes 2,000 hours to manufacture one glove of a spacesuit.
Okay. And
there are many layers inside, one of them being what is considered the membrane, the bladder, which is what keeps the air inside of the suit. And this is done traditionally by dipping a mold into a rubber compound at certain temperatures, and then you have to cure it, et cetera, et cetera. And this is just one of the layers. What we're doing now is changing that technology that requires a lot of time by using 3D printing materials with flexible filaments, like, for example, this joint that I have here, which is fully 3D printed and is completely flexible. So what allows you to do is just in a few hours, the work that otherwise you have to do with very complex rubber, neoprene equipment, et cetera, et cetera. So what it allows you to do is you have the files, you have the material, you have the printer, anyone can do it, especially a trained astronaut, right? So if your glove breaks on Mars, you don't have to wait 2 years until the next ferry from NASA can show up here with the new glove. You can manufacture that wherever your destination is. So I think it will be very important that we start reducing our dependence on the Earth if we really want to become a multiplanetary species. So this is just, of course, one tiny bit. We have to look into the variety of different systems, equipments, and consumables that the astronauts will need on such a long duration flight.
It really is amazing just how complex and how difficult it is to put together these different spacesuits. And there really is a different spacesuit for each occasion, whether it be microgravity or being on the moon. It's absolutely fascinating. I was reading that there's up to 14 layers of spacesuit for every single one, and all of it has to be created almost perfectly to ensure the safety for the space person. But Iain, I know you had a question for Dr. De Leon.
Right. So with the 3D printing, it's usually printed in layers depending on what type you're using. And to pressurize it, you have to make sure all those layers are together and fused correctly. So how are you planning on facilitating that?
Well, right now in the way that we do, it depends in the specific part that you are printing, but in some cases we preheat the area where you are producing the print to keep the plastic at a certain level of temperature that the different layers will keep adhering to themselves. For example, before the program, I was showing you this is a glove disconnect that is a prototype, and we printed that with another carbon fiber printer that I have here just beside me that will allow us to, instead of making these portions in metal that take hundreds of hours to do in CNC, like late systems in aluminum, we'll be able to do it in carbon fiber. So in just a half a day, right? So it reduces the time and it reduces the skill that the person that will have to print it on site will do it. So right now we are unable to do everything in just one printer. Like I showed you before, we have 2-3 different printers where we work on different systems. But in reality, in the future, the astronauts will need a variety of printer systems. Now we're talking of printing burgers or pizzas, something like that. So I think that additive manufacturing will become on a necessity, a very important portion of the equipment that the astronauts will take with themselves for long duration missions, right?
So can we go back to the talking about printing burgers and pizzas? No, I'm kidding. That did sound kind of interesting. So Dr. De Leon, one of the things that we like to talk with the aspiring young aviators about is the different tracks that they can take to get to a point in terms of opportunities in schools like UND, Embry-Riddle, et cetera, and so forth. And one of the aspects that comes up quite a bit is what should I major in? So you mentioned that you majored in aerospace engineering. I have had I've had people from the Jet Propulsion Laboratory and from Northrop Grumman, et cetera, and their major was electrical engineering or mechanical engineering or things of that, or maybe not even engineering, something else. Can you speak to that a bit with all your experience and the different students that you have in your classes as it relates to not only spacesuits, but just getting involved in human space flight?
Well, I think space is a topic that includes, in one way or the other, probably all disciplines of human knowledge. When we talk about creating a appendix of our civilization in our natural satellite or in another planet, there will be needed people that know all the disciplines of humanity. We'll need doctors, we'll need dentists, we'll need interior designers, we'll need, of course, engineers of all sorts, we'll need pilots, and we'll need structural engineers, and we'll need, I can't think of any of a particular discipline of human knowledge that don't have to be included as we move farther from our planet, right? Because wherever we go, we'll have to take a little bit of each. So we have a variety of students that come from the most diverse disciplines. We had students who were journalists and they want to become space journalists. So they wanted to get more into the technical side to be able to understand the language of the engineers and the scientists and be more proactive, more knowledgeable in the way to communicate to the audience the different topics. So of course, most of our students are in the engineering kind of science or engineering, most of them, mechanical engineering, aerospace engineering, chemical engineering. But I think that space is open to everybody, and all disciplines will be required in one way or the other. And we have to take that into consideration and be very serious about that space is not just the realm of a bunch of engineers like me, but everything will be required, and we'll have to adapt all our different lines of knowledge to this new possibility that we're facing.
So I have to say, you're another cool engineer, because some of the engineers I've met in these programs, you think of engineers, no offense, nerdy or whatever, but you guys are actually pretty cool and a lot of fun.
Yeah, well, you know, I really believe that, and of course, engineering is important, but there are so many interesting things that you can do in space, and I really believe there was this Russian scientist. He was a school teacher actually in the 1860. Konstantin Tsiolkovsky. He said. The Earth is the cradle of humankind, but humans don't have to stay in the cradle all their life. And I think that at this point we gain enough the technology. We are at the point in history where we are able to master the technology that is required for us to move outside of our planet. At the moment, at a pivotal moment where many of our resources are diminishing here on Earth. So we'll have to look around and see if there is any place else. Otherwise, we're limiting our growth as humans, right? And I don't want to think. Sometimes some people said, well, you know, we have to limit our growth and go smaller and do this less and less and less. And I don't think so, because, you know, we're living in an island. But there is a universe of possibilities, and there is a universe of resources, a universe of energy. So when someone tells me, oh, we have to use less energy, because I look at the sun and I said, I mean, we're using nothing of the sun. We have plenty of energy to do whatever we want to do, and it's just sitting there. So what are we doing about it?
Speaking of somewhat leaving the nest, I did read a little bit about your experience with NASA. And if I understood correctly, you were the payload scientist for the a mission that they flew, the NASA KC-135.
Yes.
For those who aren't familiar, it's basically an aircraft that goes up to about 35,000 feet and performs different parabolas. And at the top of that parabola, you're able to be in zero-G environment for about 20 to 30 seconds, and you do that for about 2 to 3 hours. What was that like, and do you think, excuse me, what was that like, and do you think that normal individuals like doctors and lawyers would feel comfortable being in that zero-G environment?
Well, it's a very alien environment, because we humans have been supported by something since we were born. We were sitting, we were laying down, we were standing, and all of a sudden you are on this crazy airplane that I won't mention the nickname of that airplane, but you are supported by nothing. So it takes a while to your senses to get in tune with what's going on, because it's a very, very weird situation, especially because you go from 0G to 2.5 Gs and then 0G again and 2.5 Gs. So it's not like being, you know, an astronaut that you say, okay, I'm going to stay in this situation for 6 months, so I better be used to. But this is a very dynamic environment. So, you know, more than half of the people in the airplane get sick very quickly, and then everything turns.
I did read it's known affectionately as the vomit comet. That aircraft.
Exactly.
So I'm just kind of curious as far as like the mental state and the physical state, what that would be like to stay in that zero gravity for so long. Would people, normal people like myself, like pilots or even dentists, if they would need kind of a, I wouldn't say excessive, but a large amount of just mental strength training in order to be able to be in those environments for prolonged periods?
Yeah, something that many astronauts told me is that they don't see a correlation between astronauts who do very well in aerobatics, pilots who are very familiar, that they take the T-38 Talon and they just do everything, and then they get sick in space, while some other astronauts or pilots who normally can get some motion sickness, and then they go into space and they feel fine. So it seems like there is something else, and it happens in the general population as well. More than 60%, about 60% of the people that get into space for the first time, they feel discomfort the first days. But we humans are such a remarkable, adaptable species that in a week or so, you just feel like it was your home always. Now the record of human permanence in space is a Russian Valery Polyakov. I think the record is 427 days or something like that.
427?
Yes, 427 days in one time. So that means that the duration of the trip to Mars is kind of guaranteed if you are in fine health. And once that you arrive to Mars, you'll have 0.38 of gravity. So that means that the body will be able to acclimate itself to a reduced gravity to the Earth, but things will fall down, and that's a great improvement, right? So you can walk, you can use your toilet in a normal way. So that is a big improvement after you have been almost a year in microgravity.
Yeah,
absolutely.
Of course, it's not known yet the long-term effects of that, but we'll find out.
Iain, would you want to be in space for 472 days?
I think it'd be very cool, but I was wondering, so it has a lot of effects on the body that we've seen through tests after people come back from space. What are some of the long-term effects from that, especially being in space for that long?
Well, recently, as you know, NASA finished a study, call it the twin study, because there were two brothers, Kelly brothers, Scott, and I can't remember now the name of his brother, both astronauts. One of them was on Earth while his brother was doing an almost a year mission to the International Space Station. So they did found differences, but nothing that with a few weeks of readaptation was not able to kind of go back. So what we know right now is that at least 1 year, humans can stay in microgravity with non-permanent effects, other than a certain increase in radiation doses that you'll have an increased risk of developing certain illnesses, which in the case of when you are in lower orbit, you are still protected by the Van Allen belts. Now, when we are talking of a transit, say you leave the protective cocoon of the Earth and then you go on transit to, say, Mars, you are way more exposed to radiation, right? And this is something that we have limited experience with. Only the astronauts who flew into the Apollo missions were subject to being flying in kind of in that open environment. So there are preliminary studies about an increase in radiation risks. NASA is looking at a variety of ways to shield the astronauts from that. One of them is as simple as this, is putting the water tanks of the spacecraft around the sleeping compartments of the astronauts, because you'll spend there 8 hours anyways per night. So you'll be protected during 1/3 of the time, and water will protect you from a certain degree of radiation that is fairly harmful. So that's one of the ways. And there are a lot of other studies. Some of them are even electromagnetic that are being looked at right now.
Yeah, I was going to ask about that, but first I want Iain, so what do you think so far? I mean, have you gotten some enlightenment about some of the things that you've thought about in terms of human spaceflight?
Yes, very much so. So you were talking about the water tanks around the outside of the spacecraft. So you were saying just around the sleeping compartments, but that would be a large amount of weight. And
yeah, which you will have to take anyways, because it's the water that will be consumed on board and will be recycled by the life support system to drink it over and over again during your flight. But yes. Mm-hmm.
Okay, very cool.
Yeah. Go ahead.
So talking about getting to be an astronaut, what are some things that colleges, universities look for in someone like me coming out of high school?
Something that is very important is to see that there was a demonstrated interest by the prospective student on something that deal with STEM. that you can, okay, you know, when I was in, I don't know, elementary school, I did this little experiment or something like that, and then I did this other thing, and then I did this other. As you are growing, it shows a continued interest on that, and sometimes that is even more important than good grades, you know, to show that you have a permanent interest in developing your skills. I look at applications from students all the time, and I see that the students who are more successful are the ones that are persistent, in the sense that they are persistent in their interest to reach a goal, you know, become an astronaut, work for JPL making robots for Mars, you name it. But where you can show over time that you have an interest that doesn't go away, right? That you're pursuing a dream, that you're passionate about something. I think that's super, super important.
Very cool. Thank you.
Mm-hmm.
Yeah. Let's talk a little bit more about the spacesuits for a second. I wanted to ask you the design of the suit that they wear to go to the space station right now on SpaceX.
Yes.
Yeah. So the first thing everybody looked at is like, wow, that's really cool. And that's really different. How did that come about, that design, and why?
Well, we have to look at suits in their proper context. When we discuss, for example, the suits of SpaceX, like the one that I have here in the back, those are called intravehicular spacesuits, or IVA suits. What it means is that suit will only protect you in case that you have an explosive decompression of the cabin. So it's not a suit that you can go outside open space and do your repairs or anything like that. It only works so it can protect the astronauts in case that something goes wrong in the cabin. You have a leak into seal, and you start losing pressurization. So the life support system will detect that reduction in atmospheric pressure, and it will seal the suit, and your oxygen will come in on a different source, so it will keep the astronauts alive while you are taking care of the problem. Or if you are hit by a piece of space debris, you know, a bolt that is just in the wrong orbit and, you know, hits your capsule, that can happen because of the large speeds that you can encounter another object in orbit. And NORAD, through the Air Force, is tracking most of the space debris elements of certain size, but very, very tiny elements are very difficult to track, and they can be in the wrong orbit, collision with your spacecraft. And as we have been since 1957 to now, creating more and more space debris that we are not taking away, the lower orbit is becoming a kind of a dangerous place. Sometimes the space station have to kind of maneuver and move around just not to hit a big piece of chunk of metal that is there in orbit. So
Sounds
these
like
suits,
air traffic control.
yeah, well, very soon.
That's exactly
yeah.
what I was thinking.
Right. Yeah, very
It really
soon.
does.
Something will have to take place on that. So in fact, there are several companies that are starting to do their business plans, create a business case of debris removal, and they can charge whoever put it in orbit and say, okay, here 2 tons of these
garbage collectors.
Yes, exactly. Yes. So there you have another.
And they say you can't come up with a new business in America.
Yeah, there are several companies that are looking into that, because at the end you're responsible for whatever you put in orbit. So, you know, eventually if someone brings it's a danger, as is happening increasingly, becoming a danger for transit of other operational satellites or spacecraft. You may be able to collect some money on that. Yes. So again, these suits, what they do is just to protect you inside the spacecraft. To go outside and perform what is called an EVA, an extravehicular activity, you need more complex suits, which can withstand the difference of in temperature, that will protect you from the sun radiation, other things that these suits won't do because they are too simple.
Right. And the more complex ones for EVA, that's also for, there's also a comfort factor, right? If you're going to be out there for several hours or whatever, you don't want to get fatigued. So I'm sure you guys deal with that, or yes? No.
Yeah, it's very difficult to do really, because astronauts, when they go outside in a extravehicular activity, they can spend up to 8 hours doing their work. And the thing with this kind of gloves is, as you can see, they are very heavy, which of course in space doesn't matter that much. But once that you pressurize them, they become very stiff. So it's very difficult to operate tools for many hours without getting your fingers really, really tired. So one of the challenges on spacesuit design is to try to improve the joints so they will be more comfortable for the astronauts who will be doing work for many, many hours. Also, you want to provide, in the beginning of the space shuttle program, they had a cereal bar kind of stuck in there. So if during the 8 hours they were hungry, they can kind of try to chomp a little bit of that cereal bar. But in microgravity, right, it was very difficult to get pieces of this bar all over your helmet, and you don't want to do that because you can end up breathing the thing, right?
Right.
And sometimes that happens with they have a kind of like a water bottle that is just in case because in 8 hours doing work all the time, you'll get thirsty.
Yeah.
So
and you can't do the space Heimlich.
right, exactly. Yeah. So you have this valve that is a one way. So when the valve detects that you are trying to get some water, it will open, and the rest of the time it won't. Otherwise, you have the same problem. You can breathe the liquid in microgravity, and that will be harmful for you. So
that sounds like it would be terrible.
Yes. Yeah. In fact, a few years ago, there was a failure in one of the life support systems, and an Italian astronaut, Luca Parmitano, all suddenly started to have a lot of water inside his helmet. His communication got shut, and it was a life-threatening problem. So actually, that was this. We have been getting people in spacesuits in open space since 1965. And probably the situation of Luca Parmitano was the first time where an astronaut was risking his life in a serious way.
Before turning it back over to another question from Iain, I'm sure he's got plenty of things he wants to ask you. I can see him biting at the bit with it. The other spacesuit on your left side, that's an EVA suit?
Yes, that's an EVA suit. That's one of our, and I have on this side, which with the camera we can see a number of NDX-2 spacesuits, which are lunar prototype suits that we are working with. Most of the work that we do here in the lab is about EVA suits. We specialize in surface suits, meaning suits that will walk on the surface, either the moon or Mars or eventually asteroids, and there are a number of differences between those suits and the suit like the one of SpaceX, for example, right?
Is this what your students learn about?
Yes.
And do they participate in lab experiments? And
we do a lot of, I have, in fact, in part of the lab, in the other side, I have a number of students that are preparing, and they go, I always joke that normally our students, before their ink of their diplomas is dry, they are already being picked up by either NASA or SpaceX or Blue Origin or Lockheed Martin or Boeing. So we have a 100% placement of our students, just because we have this hands-on component that they are able not just to write papers about something, but also do practical things in the lab, and being able to participate on testing and validation, certification of systems. We go to NASA centers and we participate on tests with NASA engineers and scientists. And I think that's what makes this, my work way more interesting as well, right?
Yeah. One of the big questions that a lot of students always want to know is what kind of things can they do as they're going through school, in Iain's case through high school, but then when they get to college, in terms of networking and things like that. I've had this question asked on previous shows with like Jet Propulsion and Northrop and that type of thing, to further their career opportunities and to get more involved in what they're doing. You mentioned earlier that getting involved is a key aspect of furthering your career while you're getting educated.
Yeah, something that we do is we have here in the department the North Dakota Space Grant Consortium, which is an educational organization that depends on NASA partially. So we offer the students NASA internships. They can go, and in the past, we did that with private companies as well. We had students intern in SpaceX, intern in robotics, Mars robotic companies in California or in other places. But most of our students go to Kennedy Space Center or Johnson Space Center in Houston or Ames in California for their internship. So there they can start in developing their contacts with the community. They see what are the differences and similarities with with academia, so they can see a glimpse of the real world and look at what the future will the possibilities of the future once that they graduate.
So on the topic of spacesuits, how are you managing with radiation?
Very good question. There are no many ways to protect the astronauts from radiation. Sometimes when you see in a magazine and you say, okay, the spacesuit protects the astronauts from radiation. Yes and no. It protects you from this radiation of the sun in the eyes and the skin of the astronaut, but you can't really protect if there is a solar storm, something of the sort, the suit is not going to protect you. They are just less than an inch of fabrics in between, and that's not going to work. You know, you have to get something different. For example,
so is it something on the ship then?
Something on the ship, or something if you're on the surface of the moon. What you do is you cover your base with lunar regolith, or if you're on Mars regolith, about a meter of Mars regolith on top of the modules of the vehicle will protect almost 100% of the radiation. But when you are outside and you have a situation with solar radiation, there is really nothing you can do other than just search for shelter. It's one of the many risks of space exploration.
In 8th grade, we were talking about, we did a project for the US Army, and it was talking about putting a base on Phobos, one of the moons of Mars. Mm-hmm. And one of the ways to protect from radiation was to put that regolith on top of the base.
Yeah, that's the way it works, right? And chances are that in the near future, something else will be discovered, you know, because there are a lot of studies on, as I mentioned before, about electromagnetic shields that may be able to deflect and protect. But right now, the only thing we can do is just to protect it, as I said, with water tanks around the areas, or regolith, which will protect you 100% while you are inside the shelter, right?
Yeah. I'm going to step in for a minute. I want to go to Brooke. And Brooke, you have had an interesting track to get where you are. You know, you go all the way back to, actually, I think it was your father that suggested that you consider the pilot track
Yes, it was.
and start heading in that direction. And then had a hard stop last year because of COVID-19. And since being a guest on this show and watching some of the programs, some of the All Things Aviation and Aerospace shows, you seem to be forming some new opinions. Can you give us an idea of what your thinking is right now as somebody who recently graduated and was on the professional pilot track and has a love for aviation the way you do?
Yeah, absolutely. It's been interesting. I wouldn't say that time is wasted as long as you're learning. So this last year with COVID and most of aviation coming to a bit of a halt, if you will, I think what's on most pilots' minds, including myself, is where can I put myself where there will be job security in the future? So what is expanding, what is growing, and what can I learn more about in order to get myself deeper immersed into that field, make connections, and learn what they're looking for specifically in those fields. One of them that I've been looking into is space studies, especially being in Florida. We have the Space Coast. There's always, launches going off once a month, it feels like now, especially with all of the SpaceX launches going on around. But I've definitely been looking a little bit more into that portion of aviation, and it's kind of opened my eyes to just how massive and how many different roles there are in space exploration. So definitely looking into portions of that, as well as cargo too. Cargo is sort of like the I wouldn't want to say backup plan, but something that I am also very interested in, because I think that there's a lot of job security in cargo right now, especially with more direct to consumer markets emerging every single day. It just gets easier to get something shipped to the house. So those are two avenues that I wasn't originally looking at that I'm definitely learning more and more about. And it's been quite interesting to learn.
So, Professor, if you were advising her and encouraging her in terms of the space program opportunities, what would you say?
Well, several things. I believe that, life is long enough so you can do several different things depending of how you feel like, and you can be one thing, and I would say that probably this will be really the future of the workforce, right? That you'll have to reinvent yourself every few years just because things are changing so rapidly. Sometimes forced by this natural circumstances like we had with the pandemics, and sometimes just forced by evolution and the needs of the markets. So I think that at the end you have to do whatever makes you happy, and that can change over time. And sometimes, you can be a commercial pilot. In one point of my life, I started flying when I was 15 or 16 in Argentina, gliders and
Oh, wow.
J3 Cubs. And
That's
at that
awesome.
time, I kind of entertained the idea of being a commercial pilot. Of course, space was more interesting to me, but I kind of looked at the idea. And at the end, I said, no, I'll just pursue my dream, which is space. I saw it as a sort of a shortcut of some sort. But, you can say, well, I want to be a commercial pilot for a few years and until I get tired of it and then do something else. I see it with my students all the time that they do something. They are in the military and then they retire. And then they get masters in space studies. And then they go to work for SpaceX or for NASA. And then in a few years, they want to go to academia and become professors. So, I think what is important is to have the maximum an open mind and saying, okay, I'm gonna enjoy my life doing what I like for as long as I want to keep doing it, and then I want to be educated enough to the point that I can choose to do something else.
Yeah, that's really good advice. Being able to just evolve every so often in your own career. I did have one last question for you if we have some time left. A very close friend of mine, Sal, he is in Embry-Riddle's graduate program and he's working on his space system certificate. He absolutely loves all things space. So I asked him if he had the opportunity to ask you a question, what it would be. And the question was, what would you consider to be the biggest hurdle of Mars exploration and colonization, in your opinion?
It's not technical. My answer won't be technical because I consider that all the scientific and all the technical questions regarding reaching Mars are solved one way or the other. We know how to get there. We have the rockets, something like, the Starship, or even the Falcon 9, the Falcon Heavy, or the SLS eventually will get us to Mars, and assembling something in orbit and get, so, the problems are solvable. The biggest hurdle is continuation on the desire is politics at the end, because is that having that continuation, an ambitious and costly program like that requires a long time.
Yeah,
at least
a lot of
at least
commitment.
at least 10 years. So you need to have a continuation of policies that will allow you to get that done. I think so the hurdle is non-technical, is political, I have to say.
And I think the commitment that I'm sorry, I was going to say the commitment you're talking about is a commitment that we had back in the day with the Apollo program, where it was like, do what you have to do, we'll find the money, make it happen, and they did. So listen, we have about, go ahead.
No, I'm sorry. I think that Brooke wanted to say something.
Yes.
Yeah, I just wanted to add to that, with the more private sector of exploration, such as SpaceX and more programs like that emerging, do you think that would be something we would have achievable maybe in, within my generation potentially?
Absolutely. Absolutely. However, remember that all the funding from SpaceX, or 90% of the funding from SpaceX, came from the federal government. So when we talk about commercial space,
Hello? Did he freeze?
I think
so.
we may have lost him.
We lost him.
oh, I'm sorry.
There we go. He's back.
Oh, there he is.
Yeah.
Sorry
about that.
We lost you when you were talking about the financing coming mostly from the federal government.
Right. And I think that funding needs to be there to keep developing these companies. And eventually these companies will find a business case to be able to keep going. But I think that it's necessary to keep developing this technology because, again, most of the technology from all these new companies came from NASA. Don't forget about that. It came from the taxpayers' money. So was not developed, say the Pika X thermal protection system for the Dragon capsules was developed at NASA Space Center, and NASA loaned one of their scientists for a year to SpaceX to have it developed. So most of the technology came from the public sector, and we have to remember that.
Sure.
So
go ahead, Ian.
Due to the fact that most of the funding comes from NASA, how much of a say does SpaceX have in what actually happens with the mission?
Well, of course, projects like the Starship are private developments. NASA is not paying for those. Those are done with SpaceX money, and I think that's absolutely great. But in the beginning, the NASA funding was there to support and keep supporting through the crew and cargo program with the space station and stuff like that. So I think it's important that that funding continues so these companies can keep developing their vehicles and take us to the next step.
Ian, we have time for another question or two. You have any other questions for him?
Just that spacesuit on the right you have on the right of you there, that was for Mars, you said, or the moon, I think.
Oh, I'm sorry, I have it inverted here. No, this is NDX2 is a prototype for the moon environment. So it's a heavier spacesuit. It's a suit that you enter through the back, like the Russian spacesuits, or like the XEMU that will be used in Artemis program.
Is it a one piece?
Is a one piece, yes, it is a one piece, yeah. And it's heavier, and because you can afford it on the moon with 1/6 of the gravity, you can afford a heavier spacesuit that will be more redundant. While for Mars, because you're talking of 1/3 of the gravity of the Earth, you have to build a spacesuit that will be lighter. So that's one of the challenges as well, building a spacesuit, especially a life support system that provides you oxygen and removes the CO2 and keeps you the temperature, etc., for that period of time, right? So
due to the fact that it's a one-piece suit, how would you think about manufacturing that when you're in space?
Oh, you assemble in different pieces and you just bolt it together and put it together. Yeah.
Okay.
Yeah.
We have about 5 minutes or so. So Ian, if you have any other questions or comments, now's your chance.
So you said there's not very much radiation protection
in a spacesuit, no.
With the spacesuit, but on the base, we were talking about the regolith.
Yes.
How would you get that regolith from the lunar or Martian surface on top? Because without machinery, that's very hard.
Well, the thing is, you'll have to have adaptable systems with machinery. That's why I am very supportive of robots and humans working together. I think that we'll need to establish a base that will be robotically installed before the humans show up. So if I were the head of NASA, that I will never be, but that's another point, I'll say, okay, let's send the robots first, create our bases there with robotic aid, and then launch the humans when we know that the bases are already established and ready to go. Of course, the astronauts will still have to do a lot of work, but the robotic systems is not one or the other. It's robots and humans working together. And that's why I think that is a very fundamental work, that you have large robotic systems like, the one that will be landing on Mars next month, which is kind of the twin brother or sister of the Curiosity. I think it's Perseverance.
Perseverance, right? Exactly.
So robots,
I was going to say JPL is sending you a lot of love right now.
Right. Yeah. No, I think, it's very, very important. And those robots will be able to move ground and flatten the surface and help with a lot of things, not only scientific tasks, which they did so well since 1976, the Viking missions, but also to try to help to create this infrastructure that we'll need to thrive on the red planet.
If I had any takeaway of everything that you've said, which has been everything you've said today, the robots and working in conjunction with, human activity, that makes so much sense, especially to send the robots first and have them set up and do things that they can be tasked with, and then follow up with the human element of it. That just makes total sense. So yes, you should head up NASA.
Well, I won't, but I think in fact Jim Bridenstine, who just recently departed from NASA, I think yesterday, was here in the lab, just visiting our lab and giving us some advice on all the different things that we're doing, etc., etc. So anyways, yeah, that was a very interesting visit that we had just a few months ago.
Iain, chance for one last question before we wrap up. Sorry, Brooke, go ahead.
That's okay. Are students able to get tours of the campus if they wanted to go to UND and check out your
Oh, sure. Yeah, we give
office.
tours. Yeah, we give tours all the time. Even with this COVID situation, we are giving tours, and this is just one of the areas. We have a lot of different sections in the lab, in the department, and we have a habitat that is just less than half a mile from here, where we simulate entire missions. You can check on the internet. We have an entire array of modules all connected together. One is a plant module where we grow plants during the analog missions, and the other one is an EVA module, and an exercise, a human performance module, a geology module, and also you have living quarters with the tiny bunk beds and everything. And we do
amazing.
Missions of several weeks in duration, where we put students there and they have to do experiments like they were living on Mars.
Wow,
yeah,
that's pretty impressive. Iain, one last question.
Are you taking high school interns?
Well, not right now, but we can talk about that. Okay, we can talk about it. But certainly, Iain, keep me posted of your progress. I will be looking forward very much to see how you're doing, and of course that the doors of the Department of Space Studies are open for you when the time comes. Okay.
Yeah, this has really been great. Dr. De Leon, with regard to everything that you do with the Space Studies program, and just so many interesting aspects of it that you've talked about, including the most recent one of just talking about this setup you guys have of a habitat setup. That sounds pretty cool too. I'm with Iain. You have adult internships? This has been great having you on, and you as well, Brooke, talking about things from a post-college perspective as you delve into your aviation career. Iain, I hope this was helpful to you in terms of getting some insight about human space flight and just all aspects of the space program for your future, which you're still in the early stages of, but boy, are you way ahead on a lot of things with the questions you were asking. So really terrific to have you guys on board. We really appreciate that.
Thank you for the invitation.
Yeah, thank you.
Yes,
thank you very much for participating.
Thank you.
Yeah, great to have everybody. I hope that our audience, also our viewing audience, enjoyed the information that was given today. And we want to thank everybody for watching All Things Aviation and Aerospace. My name is Vince Mickens with the Private Air Media Group, and wish you guys well. And we'll talk to everybody soon. Take care, everybody.
Bye-bye.
Bye-bye.